In this video, we're going to look at different ways to factor polynomials. When we factor polynomials, we need to make sure that they are in standard form. Standard form means the terms are organized with the highest degree going first. So if I look at my polynomials down below, this second polynomial is already in standard form because that exponent of 15 is the highest, and that means that it needs to go before the term with x to the 7th. Looking at this first polynomial, it is not yet in standard form because they're out of order. The term with the highest exponent, the highest degree, needs to go first. So x to the 4th needs to go in front. From there, our terms should slowly decrease by exponent. So after x to the 4th would be 4x, since the exponent there is 1. And then our constants that don't have any variables will go last. With that in mind, we're also going to utilize some factoring strategies that we've seen with quadratics in the past. The first one is a greatest common factor, or GCF. In this first example here, 10x squared minus 5x, I want to break that apart into factors, and I notice that there's a greatest common factor of 5x between those two terms. That GCF is going to go out in front, and in the parentheses I'm going to write what I have left over after I divide each of those terms by 5x. 10 divided by 5 is 2. X squared divided by x is x. Negative 5x divided by itself is going to be negative 1. A second method of factoring with quadratics is the trinomial method, where you have a leading term of x squared. This is our pattern strategy where we're looking for two numbers that multiply to the end and add to the middle. So in the case of 7x and 12, two numbers that multiply to 12 but add to 7 would be 3 and 4. My factors then are going to be x plus 3 and x plus 4. Our last strategy that we're going to use is the difference of squares strategy. This is only if I have a difference, a subtraction sign, between two perfect squares. For this strategy, we're going to take the square root of each term. Square root of x squared is x. Square root of 16 is 4. One of my factors is going to add those two together, and one is going to subtract. Now we're going to factor with the GCF for non-quadratics, for other polynomials. In this first example on the left here, I have three terms: 2x cubed, 10x squared, and 12x. For my GCF, that factor needs to be common to all three terms. So all three of those terms share a 2 and an x. They all have a factor of 2 and all have a factor of x. That 2x is going to go out in front, and in my parentheses I'm going to have what's left after I divide each of those terms by that 2x. Another way that you can think about what's left over in the parentheses is to think about distributing. If I were to distribute that 2x back in, I should end up with the function or polynomial that I started with. So that might be a helpful way to approach it. 2x times what would give you 2x cubed? The answer there is x squared. For that next term, 2x times what would give me 10x squared? 2 times 5 is 10, and x times x is x squared. Last round, thinking about what's missing, 2x times what would give me 12x. 2 times 6 is 12, and I already have the x, so I don't need to multiply it with another one. When checking to see if you are done, you have to make sure that you can't factor any more. If you can factor further, then you need to factor as much as possible. So looking at my parentheses, x squared plus 5x plus 6 is factorable. That's my trinomial where I have x squared in the front. I can find two numbers that multiply to 6 and add to 5. They are 3 and 2. So my parentheses factors further, breaks down into x plus 3 and x plus 2. I can't forget my original factor, my GCF of 2x, giving me my final form, 2x times x plus 3 times x plus 2. I want you to pause the video and try the second one on your own. Check back in when you've given it a go. All right, in the next one I started by factoring out the GCF of 2x cubed. When I divided that out in front, I was left with x squared minus 9, which was a difference of squares. Square root of 9 is 3, so my second and third factors here, x plus 3, x minus 3, came from the x squared minus 9. Don't forget that greatest common factor stays out in front. Our next method of factoring is called factor by grouping, and this factoring method is utilized when we start with 4 terms. What we're going to do is we're going to break apart those terms into 2 groups of 2. We're going to slice this polynomial right down the middle. With each half, with each group, we're going to find the greatest common factor, the GCF, within each. So it's almost like we have too many factorings in one. So on the left-hand side, those first 2 terms have a GCF of x squared. I'm going to pull that out in front. When I do, I'm left with x and a negative 1. In the second half, I have a greatest common factor of 2. When I divide that out in front, I'm left with x minus 1. My next step is to now GCF again, a third time. Okay, I'm going to GCF each group now together, looking at it as a whole. I notice that each half shares a factor of x minus 1. I'm going to pull that factor out in front, and what's going to be left from each part were the original greatest common factors. Those are going to combine to create the second factor, x squared plus 2. In factored form, my polynomial is x minus 1 times x squared plus 2. We'll try another one together. We're going to start with 4 terms and break those terms down into 2 groups of 2, slicing it down the middle. For each half, we're going to think of it as a mini factoring. We're going to find the GCF of each. So in my first half, x cubed plus 5x squared, there's a common factor of x squared. I'm going to divide that out in front. I'm left with an x plus 5. For the right half, these 2 terms share a factor of negative 9. That negative 9 is going to break out in front. Negative 9x divided by negative 9 is x. Negative 45 divided by 9 is a positive 5. If I do it correctly, these parentheses should match. And my last step is to GCF one more time. This time looking at the full polynomial. The full polynomial, those 2 halves, have a common factor of x plus 5. That's going to form the first factor. My second factor is the combination of my GCFs, x squared minus 9. What makes this one a little bit trickier is that we can factor further. X squared minus 9 is a difference of squares, so that one's going to break apart even further into x plus 3 times x minus 3. I'm going to drop down my third factor of x plus 5. So this one factored into 3 factors. Our last method of factoring is called quadratic patterns. You'll notice that in these 2 examples, there's no greatest common factor other than 1, and we don't have 4 terms. So we're not going to be able to GCF, and we're not going to be able to factor by grouping. These are trinomials, but you'll notice that they begin with x to the 4th power. We're used to our polynomials beginning with x squared. We're going to use the same pattern finding that we did with quadratics, looking for 2 numbers that multiply to the end and add to the middle. In the case of the example on the left, those 2 numbers would be 6 and 1. We're going to create our factors just like we did before, with plus 6 and plus 1 forming the second half of those factors. But now I need to break apart x to the 4th power. So each of my parentheses is going to get an x squared, unlike with our quadratic where each parentheses got an x. I want you to pause the video and try the one on the right. Press play when you're ready and check your answers. Here we were looking for 2 numbers that multiplied to -24 and added to -5. They were -8 and +3. That x to the 4th power breaks apart into x squared and x squared. Neither of those factors can be broken down any further, so I am done with my 2 factors of x squared minus 8 and x squared plus 3.